Say goodbye to overwhelming textbooks and hello to vibrant, interconnected mind maps. We welcome you to our new series of videos where we pick each mind map from our mind map bundle and help you run through all the important points you need to remember for your exams. You can browse our app while watching this video and download the mind maps for enhanced retention. So, let's get started. In this mind map, we will go over some important concepts related to water, which is an important topic in public health dentistry. Water, the elixir of life, is essential for our well-being. Potable or drinking water should be free from pathogens and harmful chemicals and should be typically colorless, odorless, and tasteless. Pure water should be devoid of all disease-causing microbes. This water is what we're ultimately going to use for all our daily domestic needs. Coming to water supply and requirements. The recommended amount of water for an individual's daily consumption is around 2 liters. For overall domestic use, the recommended range is between 150 to 200 liters per capita per day. We will come back to the points on this side of the mind map in some time. Let's first go through the concept of water hardness. Water hardness refers to the concentration of dissolved minerals, primarily calcium and magnesium ions in water. The hardness of water can have an impact on various aspects, including its soap-destroying power. There are 2 types of water hardness: temporary or carbonate hardness and permanent or non-carbonate hardness. Temporary hardness is caused by the presence of calcium and magnesium salts of bicarbonates in water. It can be removed through various methods, including boiling the water, adding lime, or sodium carbonate, or using processes like the permutate process. Permanent hardness, on the other hand, is caused by calcium and magnesium salts of sulfates, chlorides, or nitrates. It cannot be eliminated through boiling alone. Methods to remove permanent hardness include adding sodium carbonate or using processes like the base exchange process or permutate process. Water hardness is often classified based on the concentration of minerals in the water. There are 4 basic categories of water. These categories are decided on the basis of the hardness level of the water. If the hardness of the water is below 1, it is classified as soft water. If it is above 1, it is hard water. Hard has 3 subcategories: moderately hard, hard, and very hard. Between 1 to 3 units is moderately hard. Between 3 and 6 units is hard water. Very hard is when it crosses 6 units. When it comes to ensuring the purity of our water, purification methods play a vital role. Let's explore the 2 main methods of water purification: small scale for households and large scale for broader communities. First, let's go over small scale. They include boiling, chemical disinfection by various means, and by use of various filters. Boiling water is one of the simplest and most effective methods of disinfection and is something that we must have all seen at home. Apart from that, chemical disinfection is also encountered in daily life through the use of bleaching powder, which is also known as calcium hypochlorite. Chlorine solution or household chlorine bleach is another option for disinfection. High-test hypochlorite, which is a more concentrated form of chlorine, is another chemical used for disinfecting water. Chlorine is also available as tablets known as halozone, containing a precise amount of chlorine that can be used for water disinfection. Lastly, iodine or potassium permanganate can be used to disinfect water. The third method is filtration, which is done by the use of different ceramic filters like Pasteur-Chamberlain filter, Berkefeld filter, and Katadyn filter. An easy mnemonic to remember these would be PCBK. Many Indian households had water wells as their primary source of water. To make the well water pure, the double pot method was devised by the National Environmental Engineering Research Institute in Nagpur. This method involves using bleaching powder or calcium hypochlorite as a chemical disinfectant to treat well water and make it safe for consumption. Moving on, one of the most important subtopics that you need to master for your competitive examination is the purification of water on a large scale, which involves various processes to ensure its safety and quality. The three main methods to remember here are storage of water, filtration of water by slow or rapid sand filters, and disinfection by chlorination, ozonation, or UV irradiation. First, we have storage of water. Water is stored in large tanks or reservoirs, allowing the physical settling of about 90% of suspended impurities. During storage, organic matter is oxidized by aerobic bacteria, and pathogenic organisms present in the water die off. The next method, filtration of water, can be achieved by the use of slow or rapid sand filters. Slow sand filters consist of a bed of sand with a slimy growth layer called the Schmutzdecker or vital layer. The water passes through this layer, which acts as a biological filter, removing impurities. The formation of the Schmutzdecker is known as ripening of the filter. Rapid sand filters operate by mechanical filtration, using a bed of sand to trap impurities. Backwashing, which involves reversing the flow of water through the sand bed, is required periodically to clean the filter. Lastly, disinfection of water can involve chlorination, which is adding chlorine to water. Chlorine, when added to water, forms hypochlorous acid, or HOCl, which is a strong disinfectant. Hypochlorous acid acts by damaging the cellular structures of microorganisms, thereby killing or inactivating them. Another method is ozonation, which effectively disinfects water by destroying microorganisms and removing organic compounds. Ultraviolet radiation is also used for disinfection. Let's note some points in comparison of the two types of filters, that are rapid sand filters and slow sand filters. These points can be memorized under headings of space, filtration rate, effective size of sand particle, which is the most important to remember, preliminary treatment, washing, loss of head, bacterial removal, and mechanism of action. Coming to the first point, space. Rapid sand filters require less space, while slow sand filters occupy a larger area. In terms of filtration rate, as the name suggests, rapid sand filters have a higher filtration rate, typically 5 to 15 cubic meters per hour per square meter of sand bed, compared to 0.1 to 0.4 cubic meters per hour per square meter for slow sand filters. Moving on to the most important point, the effective size of sand used in rapid sand filters is smaller, 0.4 to 0.7 millimeter, compared to slow sand filters, 0.2 to 0.3 millimeter. It can be remembered by stressing on the fact that the size of the rapid sand filter particles is almost double the size of the slow sand filter particles. Preliminary treatment in rapid sand filters often involve coagulation and sedimentation, while slow sand filters rely on plain sedimentation. When it comes to washing, rapid sand filters are backwashed to remove accumulated impurities, while slow sand filters require scraping of the sand bed. Next point to note is loss of head. Rapid sand filters tolerate a higher loss of head due to clogging, about 4 feet compared to 6 to 8 feet for slow sand filters. Bacteria removal is another important point to note. Slow sand filters achieve a bacterial removal rate of 98 to 99%, while rapid sand filters provide a higher removal rate of nearly 99.99%. Lastly, we have mechanism of action. In rapid sand filters, it is essentially physical. In slow sand filters, the process is both physical and mechanical. Chlorination of water, which we mentioned in brief earlier, is an important method of disinfection, and its effectiveness is attributed to the presence of hypochlorous acid. Let's memorize some key points related to chlorination, like what is disinfecting action, breakpoint chlorination, chlorine demand, and recommended contact period. First, we have disinfecting action, which is the same as we have already discussed. The next aspect is breakpoint chlorination. Breakpoint chlorination refers to the addition of chlorine to water until free residual chlorine begins to appear. It indicates that enough chlorine has been added to react with all the impurities and organisms present in the water. Next is chlorine demand. It is the difference between the amount of chlorine added to the water and the amount of residual chlorine remaining at the end of a specific contact period at a given temperature and pH of the water. It represents the amount of chlorine consumed during disinfection. Lastly, we have a recommended contact period. Free residual chlorine, which is the chlorine available for disinfection, should be present in water for a recommended contact period. This period allows sufficient time for chlorine to react with and kill the microorganisms present in the water. We missed one important point about problem village in this section earlier. Let's go over it now. According to the National Water Supply and Sanitation Program, a problem village refers to an area that lacks access to a safe water source. It might indicate a lack of infrastructure or a lack of proper water treatment or sanitation measures. Therefore, a problem village includes areas where safe water is not within a distance of 1.6 kilometers and or water available at a depth of more than 15 meters. Villages where water is exposed to the risk of cholera or susceptible to contamination by the bacterium Vibrio cholerae, which can cause cholera, a waterborne disease, is also a problem village. Lastly, water that has excess salinity, iron, fluorides, toxic elements, which can affect the quality and safety of the water, making it unsuitable for consumption without appropriate treatment or purification methods. It is important to ensure proper water treatment, including filtration and disinfection, to provide clean and safe drinking water to communities and prevent waterborne diseases. Thank you for watching this video. We hope you enjoyed learning with the help of mind maps. The link to our app is available in the description box. You can download many such mind maps from there.